Yeah, welcome back. Now, we began looking at groups last time, and we had looked at the order of a group. Then the last lesson, we were looking at order of elements of a group. So today I want us to look at direct product groups. That is, if you have two groups and then you get the direct product, then they'll form a group. The group that is formed is what we call the direct product group. So I begin by definition and say that given a group, abelian group, G and H, you can construct a new group out of these two groups. Now, so the group we'll be forming is the direct product group, is what we want to form out of these two groups. This is how we denote the direct product of two groups. That's how we will denote it in our lesson today. Now, so what is this? It's just a set of ordered pair of elements where the first element here, the first element G, is from the first group. So G is from group G and H is from group H. So when you combine the elements of these two groups, the first element and then the second element. So the first element is from the first group and the second element is from the second group. So you come up with the elements of this new group we call the direct product group. Now, so it will be a group. It will also be a group. What that means is that it will have to satisfy all the conditions, all the axioms of a group. This new group that we are forming will be closed under the operations, the respective operations of the groups that are coming in. So it will be closed. Every element will have an inverse, and then there'll be the identity element of this group. Now, so just before we go to the example, supposing this G is an additive group. Supposing G is an additive group, and supposing H is a multiplicative group, what we know is that the identity of G is 0 since G is an additive group. And the identity of H is 1 since 1 is a multiplicative group. And therefore, the identity element of the new group, the direct product group, will be 0, 1. Will be 0, 1, where 0 is the identity of the first group and 1 is the identity of the second group. So that is how we'll be getting the identity of this new group, the new group we are forming. So and again, if G was multiplicative, if G was a multiplicative group and H was another multiplicative group, then we expect the identity element to be 1, 1. Where 1, the first one, is the identity element of the first group, and the second one is the identity element of the second group. So I hope as far as the issue of identity is concerned, that one we are clear. That's how the identity element of the direct product group will be obtained. Now, every element of this direct product group will have an inverse. So I'll be showing you how to get an inverse, but of course, we've already seen that. So for instance, supposing G is an additive group, and H is another additive group, for instance. Supposing G is our group Z8, which is an additive group. Just an example. and H is an additive group. Let me call it Z6. Supposing we have an element 2, 4. 2, 4. 2, 4 is an element in the direct product group. Is an element in the direct product group. So if I was to get the inverse of this element, the inverse of this element, I would get the inverse of 2 in Z8, the inverse of 2 in Z8, then get the inverse of 4 in Z6. And we know how to get the inverses. We know how to get the inverse. So the inverse of 2, you see this is an additive group. The inverse of 2 in Z8 is an element, let me call it D, such that 0, 2 plus D gives us the identity 0. That's the inverse. So that means the inverse of 2 in Z8 is 6. Is that okay? And the inverse of 4 in Z6 would be 2. So this will be the inverse of the element 2, 4. That will be the inverse. So again, getting the inverse is not very hard for us. It's very easy. So you just consider the group. So long as you know the first element is coming from the first group and the second element from the second group. So you get the inverse of the first element in the first group. You get the inverse of that element in the first group. The same way we've been doing. Then the second element, get its inverse in the second group, the same way we've been doing. So what I mean is this new group, the direct product group, is a group and it fulfills all the axioms of a group. One is closed, that if you add the elements of this group, you get a new element and another element of the group. Every element has an inverse. And then there's an identity element. I've shown you how to get the identity element. And then associativity is also satisfied. Now, so what I want to show you now is how to get those elements of the direct product group. That is what I want to show you, how to get. Of course, at this point, illustrates how important the direct product groups are in cryptography. So that is why we look at them, the direct product groups. They're very important in cryptography. And they're also even in homomorphic, fully homomorphic encryption, they're important. Because in fully homomorphic encryption, you're looking at two groups. And this one also, we are looking at two groups, when two groups come together. Now, so we have these two groups. The two groups in my example here are both multiplicative groups. Z5, Z star 5, and Z8 star 8. So the question is, find the elements of this group. Find the elements of this new group. That is the question. The second question is, if you have these two elements from the group, can you get their product? So that is what we shall do. And again, I'll use the example C to illustrate the same so that we understand how to get a product of two elements from a direct product. And then I'll also show you how to get the inverse of an element. And again, I'll be using these two examples just to illustrate that. Now, to get the elements of a direct product is very easy. We just do it the same way we did in high school. Now, so let me just show you that. I have Z star 5 cross Z star 8. So this is just the same as 1, 2, 3, 4, then cross 1, 3, 5, 7. Now, so the way we do it, just the same way we've been doing, I combine 1 from the first group, this one from the first group, with all the elements from the second group. and then combine 2 with all the elements from the second group, and so on. So I begin with 1. So 1 combines with this 1. That is another element. There's an element from this group. And then 1 combines with 3. Then 1 combines with 5. Then 1 combines with the 7. I'm done with 1. So I go to 2. This 2 combines with every element of Z8. So I'll have 2 combining with 1. Then 2 combining with 3. And so on. 3 with 2 with 5. And then 2 with the 7. And then I'll have 3 combined with each of the elements. 3 with 1, 3 with 3, 3 with the 5, then 3 with the 7. Then finally I have 4 combined with each of these elements. Then 4 combines with the 3, then 4 combines with the 5, and lastly 4 combines with the 7. So these are the elements of this group. These are the elements of the direct product. Now, how many are they? In other words, I'm asking, what is the order of this new group? So the order of this new group is just the LCM of the respective orders. The respective orders. So you can see the first element. No, it's just the product of the orders, just the product of the orders. You can see the first element is of order 4, has 4 elements. That is the first group. And then the second group has order 4. The product of that is 16. That means the new group has 16 elements. So when we count these elements that we have, they should be 16, I think. 1, 2, 3, 4, 5. There are 16. From this up to this element, there are 16. So that is the order of this new group. Now, what are the elements of this group? What I've listed here are the elements of this group, the new group. And I just emphasize again, the first element, this one, is from the first group. And this one is from the second group. This one is from the first group, and this 3 from the second group, and so on. Good. Now, the question is, are we able to multiply the elements of a direct product group? Are we able to multiply? And so when you multiply, you must get another element of that group. So we mean that the group is closed under multiplication. Now, to do a product of these elements, you consider the operation in each of the groups. Now, this element is from the first group, and this element is also from the first group. You combine those elements together. They are coming from a group Z star 5, which is multiplicative. So since it's multiplicative, it means we shall multiply those elements. Otherwise, if it would have been an additive group, we would have added. Is that okay? So these are multiplicative groups. So we consider this element and this element from the first group. So since the first group is multiplicative, we multiply that and get 1. Is that okay? Now, 5 and 7 are from Z star 8. Z star 8 is a multiplicative group. So it means, again, we multiply 5 and 7, get that 5. But now, mod 8. Mod 8, that means divided by 8 and write the remainder. Is that okay? So that 5, 8 there, because of that 2, the remainder is 3. Is that okay? The remainder is 3. Is it? Yes. So that is a product. That's a product of that. So you can see this an element of that group. We had that element. When 1 combined with 3, that is what we got. When 1 combined with 3, that's what we got. Let's again multiply this. But see, we note that this element is from the first group, and again 3 is from the first group. The first elements are from the first groups. And the first group is multiplicative. That means we multiply that 3 and that 3. That gives us 4. Is that okay? 3 times 3 mod 5. That gives us 4. Is that okay? Because that will be 9 divided by 5. The remainder is 4. Is that okay? Yes, that's how we do that. So we get 4. And then these other elements are from the second group. Multiplying that gives us 21. And the group is 8 mod 8. Mod 8. So 21 mod 8. That would be 5. Is it? That would be 5. So that's how we multiply. That's how we multiply those elements. Unless somebody has a question on how to multiply elements and how to get the elements of a direct product group. And of course, I've shown an example where the two groups are both multiplicative. I'll also show an example where they're both additive and an example where one is additive, another one is multiplicative. Is that okay? Because you can combine an additive and multiplicative group. Now, what is the inverse of 2, 7? The inverse of 2, 7. 2 is coming from a multiplicative group, Z star 5. So that means you get the inverse of 2 mod 5. That's what it means. Is that okay? And 7 is coming from Z star 8. So that means you're getting the inverse of 7 mod 8. And this you can do using the extended Euclid's algorithm. But this one is very easy. This one is very easy. It's very easy to see that the inverse of 2 is 3. The inverse of 2 is 3 mod 5. Is that okay? Is it? Yes. It's 3, yeah? Yes. The inverse of 2. This one is very easy to see. And even this one is. Can we see this? What will be the inverse of 7? Since the module here is very relatively small, since the module is relatively small, you can use trial. 1 is not, because 1 times 7 will be 7. 2 times that will be 14, which is not. 3 will be 21, which is not. 4 will be 28. Is that okay? I'm multiplying these numbers by 7 and seeing whether by dividing by 8 will give me a remainder of 1. Is that okay? That's what I'm doing. 5 times that will be 35. 6 will be 42. 7 will be 49. 49 is correct. Because 49 divided by 8, the remainder is 1. Is that okay? Is it? Yes. By using trial, it means the inverse of 7, therefore, is 7. And the inverse of 2, we said, is 3. Because that is in mod 5. Otherwise, you would have used the Euclidean algorithm which we learned, or the extended Euclidean algorithm and found the inverses. The good thing is for you to realize is that the first element is coming from the first group, and therefore you are getting an inverse mod, the order of the mod of the first group. Now let's do the same for this. Get the inverse of this. Oh, so this one we didn't write properly. It was, we got the inverse of 2 to be 3, and then got the inverse of 7 to be 7. And therefore, what that means, that the inverse of 2, 7, therefore, would be 3, 7. The inverse would be 3, 7. That's how That is now the answer. Because you must now combine those inverses to form one element. Now, the part E, 3 is coming from the first group, and of course, we've noted that the inverse of 3 is 2. Mod 5. The inverse of 3 mod 5 is 2. Is that okay? Because 2 times 3 is 5, is 6. And the inverse of 5 mod 8. This again, we can use trial and see. Multiply 5 by 1 is not. Divide by 8, the remainder is not 1. 5 by 2, divide by 8, the remainder is not 1. 5 by 3. 5 by 3 gives us what? 15. If you divide by 8, the remainder is it negative 1? Yes, or 7. Eh? Now, what about 5 times 7? 5 times 4. 5 times 4 will be 20. Divided by 8, the remainder is 4, which is not 1. 5 times 5, 25, divided by 8, the remainder is 1. Okay, the remainder is 1. So it means again, the inverse of 3, 5 is 2, 5. That is the inverse. So that's how you get the elements of a direct product. And of course, how you multiply the elements of a direct product. And how to get the inverses. And of course, how to get identity. I already told you. For instance, in this case, our first group is multiplicative. Our second group is also multiplicative. And being multiplicative groups, it means the identity elements are 1, 1. And therefore, it means again that the new group formed, the identity element is 1, 1. That's the identity element. Now, the next example I'm looking at an additive group multiplied by direct product group of an additive group cross multiplicative group. So the question is, find these elements, find the elements of this group. Now, what we know about the first group, Z4, is that it's an additive group and that it consists of elements 0, 1, 2, 3. Is that okay? And then the second group, Z star 12, is a multiplicative group. And we also know that it consists of elements 1, 2 is not, 3 is not, 4 is not, 5, 6 is not, but it has 7, 8, 9, 10, then 11. The elements which are relatively prime to 12. Is there any that I've forgotten? Those which are relatively prime to 12. 1, 2 is not, 3 is not, 4 is not, 5 is, 6 is not, 7 is, 8 is not, 9 is not. I think that are these ones. Now, so the question is, what is this group? What are the elements of this group? What are the elements of this group? That is the question. So that is the same as 0, 1, 2, 3 cross 1, 5, 7, 11. Combine 0 with each of the elements of the second group. You have 0, 1, you have 0, 5, you have 0, 7, you have 0, 11. We are done with 0. Combine 1 with with each of the elements of the second group. This one with each of these elements. So you have 1, 1, 1, 5, 1, 7, then 1, 11. We are done with 1. Now combine 2 with each of the elements here. Get 2, 1, 2, 5, 2, 7, then 2, 11. We are done with the 2. Now combine 3 with each of them. 3, 1, 3, 5, 3, 7, then 3, 11. Yeah, we're expecting how many elements? We're expecting 1, 2, 3, 4 times 1, 2, 3, 4. We're expecting 16 elements. That's what we have. We have 16 elements. So those are the elements of the new group we formed. So you formed a new group, and those are the elements of this new group. Now the question is, the other question A says, after you formed this group and after obtaining the elements of this new group, question A is, can we multiply 2, 7 times 3, 11? Can we multiply that? And yes, we can. We can multiply that. And how are we doing that? We are doing that by, first of all, realizing that 2 is from the first group, which is an additive group. And 3 is also from this additive group. And therefore, since this group is an additive group, we add these 2 elements. Mod 4 and get 1. Is that okay? We add these 2 elements, mod 4 and get 1. We also notice that 7 is from the second group, 11 is from the second group, and the second group is multiplicative, which means we multiply these 2 elements and get 7 mod 12. 7 mod 12, and the 12 will go there 6 times. Because of 72, and left with the 5. Is that okay? So that is 2, 7 cross 3, 11. You get 1, 5. You get 1, 5. So it's easy to multiply. Is that okay? It's easy getting this. You only need to realize which group is these elements from, these 2 elements. And you do the operation of that group. If the operation in the group is multiplication, you do multiplication. If the operation of the group is addition, then you do addition. Again, inverse. Let's find the inverse. So to find the inverse, again, you have to realize that 3 is from an additive group. 3 is from the additive group Z4. So how do we get the inverse? By subtracting the element from 4, get the inverse of 3. So the inverse of 3 in Z4, the inverse of 3 is 1. The inverse of 3 is 1 in Z4. Is that okay? Just subtract 3 from 4. But now the inverse of 7 in Z star 12. Z star 12 is a multiplicative group. It's a multiplicative group. So how do you get the inverse? I don't want to continue using trial. So we can use our division algorithm, which we've learned. Is that okay? We can use the division algorithm and find the inverse. The essence of learning that division algorithm is that when you begin writing the Rust code, and then again, that is what you'll be using. Because the Rust code, you'll not be using trial, using a division algorithm. Now, so when the inverse of 7, which is coming from a multiplicative group. So we ask ourselves, if 7 were to go into 12, how many times will that be? How many times would that be, and what will be the remainder? Is that okay? What I've written, is that okay? What I've written is okay, is that okay? And then we will ask ourselves, if 5 were to go into 7, how many times will that be, and what will be the remainder? And then we would ask ourselves, if 2 were to go into 5, how many times will that be? What will be the remainder? The current remainder we have is our GCD. Is that okay? It's our GCD. And so we reverse. Make this GCD the subject of the formula as we move upwards. Make it the subject of the formula. So what is 1, therefore? What is 1? I'm beginning from the last equation. Beginning from the last equation, therefore, 1 is 5 minus 2 multiplied by 2, which is the same as 5 minus 2 multiplied by this 2 is 7 minus 1 multiplied by 5. Is that okay? When you make that to the subject of the formula. So what do you get? What you get is negative 2. Is that okay? And this one will be plus 2 multiplied by 5. And so we are talking of plus 3 multiplied by 5. Plus 3 multiplied by 5. You know where the 3 is coming from, is that okay? Where the 3 is coming from. I just open this bracket. When you open this bracket, you have negative 2 multiplied by 5. No. Positive 2 multiplied by 5. And then there is 1 multiplied by 5 here. There's a 1 multiplied by 5 there. When you add these 2, you get 3 multiplied by 5. Now, so it's this 5 that we want to replace. It's this 5 that we want to replace now. But this was multiplied by 7 here. This was negative 2 multiplied by 7. So what we now have is negative 2 multiplied by 7 plus 3 multiplied by 12 minus 1 multiplied by 7. Is it? Just referring to this equation. I'm referring to that equation. I'm replacing 5 with its equivalent. The equivalent of 5 in that equation is 12 minus 7, 1 multiplied by 7. Opening the brackets here, you get negative 2 multiplied by 7. Negative 2 multiplied by 7. And then there is this positive 3 multiplied by 12. And then there is this negative 3 multiplied by 7. So when you collect like terms, you have 3 multiplied by 12. And is it negative 5 multiplied by 7? Negative 5 multiplied by 7. What we were looking for was the inverse of 7. And we are doing it mod 12. So the inverse of 7, therefore, is negative 5 mod 12. And negative 5 mod 12 is the same as 12 minus 5, which is 7. Is that okay? Which is 7. That means The inverse of 7 is 7. Of course, when you multiply 7 times 7, you get 49. Is that okay? 49 divided by 12, the remainder of 1. Is that okay? Yes. So that means the inverse of this element, therefore, is 1, 7. The inverse of that element is 1, 7. Now, what about the identity? What about the identity of the group? What is the group? The group is Z. Z4 multiplied by cross Z star 12. The identity element of this group is the identity element of the first group, which is an additive group. An additive group, the identity is 0. And then the identity element of the second group, which is multiplicative, is 1. Therefore, the identity element of the new group formed is 0, 1. Now, so therefore, I want to show you how to come up with the Rust code to do all this. A Rust code that will generate the elements of the group. After generating the elements of the group, multiply the ones you will want to be multiplied. And then after that, get the inverse of what you want. What I've not included in the Rust code is the identity element, because that one is easy. That one you don't need help of code to do it. Now you look at this other example. Just a minute. Now, this other example is not complicated. It's just as easy as the ones we've done. You have this group, which is a group of integers, is just a set of integers. And then we have this other set of, these are complex numbers. And then we are asked to find the direct product. You realize that the integers are infinite. And so since they're infinite, you cannot list all of them. And that is why I've used this notation just to tell how to get the direct product. Of course, we can't list all of them. So I've just said in short that this direct product will be a set consisting of GH, where G is from the first group, is a group of, is an element of the integers, is an integer, and H is a member of this set. Is either -1 or negative or positive I, or negative and positive 1. So in fact, I'm just saying that the direct product of this group, these two groups, is a set consisting of the elements GH, where G is from the first group and H is from the second group. Now, so we can do this. I think we can do this. This one says find 8, -1 cross -2i. Now we notice here that 8 and -2 are from the integers. And these integers is an additive group. It's an additive group. So that means when you bring them together, you add. So 8 and -2 put together will give us 6. And that is the 6 you're seeing here. Is that okay? Because they're coming from an additive group. So when you bring them together, you add them. And the second elements, 1, -1, and I are coming from this other group. This other group is a multiplicative group. So it means you multiply I and -1 to get -I. That's why you're seeing -I there. What about part C? These elements are from an additive group, so we add them. That gives us -4. And these elements are from a multiplicative group, so we multiply them and we get +I. And that's why what about this? The first elements are from an additive group, that will give us 12. And this one, we know that I times I is -1. That's from complex numbers. From complex numbers have a property that the square root of -1 is I squared. That's the square root of -1. No, the square root of -1 is I. The square root of -1 is I. So when you square both sides, you get that I squared, therefore, is -1. This is from complex numbers. Now, so what that therefore means is that I wanted to do part D. This is from an additive group, 5 and 7, that will give us 12. And negative times negative will be positive, but I times I is -1. I times I is -1. That's why you get that. So you get that. I think those examples are enough, unless somebody has a question. I want to show you how we can use Rust to perform this, to get direct product and then get product of groups and elements of that group. You'll go through these other examples, so just a continuation of what I've been doing. So I want to begin by showing you Rust code where both groups are additive. Just checking the ones I've opened here. Okay, I have this code. I don't know whether you can see it. Now, writing a Rust code for this particular groups is not complicated. It's not a long code. I've made it long because I wanted, first of all, to give me the elements, all the elements of the group. And then 2, I wanted to multiply the elements. And then 3, I wanted to be able to give me the inverses of the elements. Otherwise, if you would just have wanted to pick on one thing for it to do, it would be a very short code. For instance, if you just wanted to give you the elements of the group, that's a very short code. If you wanted to give you the inverse again. So this part here, this part is to give me the inverse of the elements. So I ask for an element, it gives me the inverse. Now this part is supposed to give me the sum. If I ask for the sum, it's supposed to give me the sum of the elements. This part is supposed to give me the elements of the group by combining the same way we're combining, the same way we're saying 0 combined with 1, 0 combined with 2. So that is the part that we'll be doing. And then this other part is to give me the elements of respective groups. For instance, when I talk of Z8, you should be able to know what are the elements of Z8. If I talk of Z10, you should be able to tell me what are the elements of Z10. And then I have the main function that now shows how all those are working. Now, so my initial elements, that is my mod. So for instance, in this case, I'm talking of Z10. And in this case, I'm talking of Z8. So let me see if it gives me, although there's another one that was still running, I don't know whether it will allow me to run this one. There's one that is still running. I had stopped it. I stopped it along the way. It was running, taking too long. Some minutes, let me see what I can do to stop it. Just stop the one that is running. We'll see whether this one can run. This thing of Zama, they take too long to run. They can even take a whole century. When you tell it to run, you can really wait before it stops. Yeah, I've stopped it. Stopped it now. It's no longer running. Now let me share it again. Okay. Now, so which one is this? Is it the same? This one is modular arithmetic of 2. Yeah, this is the one I wanted to begin with. Then I go to the other one. So this is when you have the two additive groups. Yeah, is the one I had shared. Where I'm talking of Z10, then Z8. These are two additive groups. So if I ask it to give me the elements of the group, ask it to give me the elements of the group, then it generates the elements of the group for me. So these are the elements of the group. So it says the direct product of Z10 and Z8 has elements 0, 0, 0, 1, all the way up to 9, 7. Now, there's a question I've asked it here. In my code, just above here, just take you above here where I'm defining my terminologies. This point, function to compute the sum of AB and EF, mod N, M. Now, so the first element of my sum, I've called it A, and the second element, I've called it B. so that I have this as AB. Then I can have EF. So if I want to add AB and EF, I must know what position those elements are. What position those elements are. For instance, when you come here, you must tell it, let AB be the 12th element, and let EF be the 11th element. Is that okay? So now it's giving you the sum of the 12th element and the 11th element. So that means, you see, that it will count those elements when you add them, when you do the way we did in that order. You begin with 0 with the first element, 0 with the second element, and so on. So it will be counting. For instance, it will count these are the first element, these are the second element, the third element, the fourth element, the fifth element, and so on. The sixth, the seventh, the eighth, the ninth, the 10th. So the 11th element is this, 1, 2. And the 12th element is this. So when you sum these elements, and you are doing it mod 8 and 10, this gives you 2, 5. That gives you 2, 5. No, we didn't count properly. We didn't count properly. The 12th element, which one is the 12th element? So it's just counting in that order. Now let's give it, for instance, 1, 2, 3, 4, 5. Let's give it 5th and the 6th element and see what it brings to us. 1, 2, 3, 4, 5. So I'll just change here and make it 1, 2, 3, 4, 5. 5. And then the 6th element. I ask you to give me the sum of the 5th and the 6th element. I want to see what it prints. I want to see whether it prints 0, 4 and 0, 5. Says what? Says, oh, the 5th element is 0, 5, and the 6th element, EF, 0, 6. 0, 5, 0, 6, the 5th and 6th element respectively. 1, 2, 3, 4, 5, 6. Which one is the first and the 6th element? Six. Seems this is not counting properly. Or is it me who is not counting properly? 1, 2, 3, 4, 5. Oh, it's not counting this 0, 0 as the first element. Why? Because I can see it's identifying this as the 5th element. 1, 2, 3, 4, 5, 6. It's identifying this as the 5th element, and then this as the 6th element. When you come to the sum, when you come with the sum, it has identified the 5th and the 6th element. I think I look at that. I look at why it's not counting this first element. That then again, the inverse again, you tell it what you want. For instance, TS if you want TS to be, in this case, I've said TS be the 13th element. The 13th element. So the 13th element, beginning from the first element. So if it's identifying 1, 2, 3, 4, 5, 6, 7, 8. 9, 10, 11, 12, 13. The inverse of 1, 4. But now it seems it's not counting the first element. So it means it's getting the inverse of 1, 5. Getting the inverse of 1, 5. So the inverse of 1, 5, again, it will do it the same way. I've told it how to do. I've told it, since these are additive groups, it will take 1 and subtract from n, where n is the mod, and then take 5, subtract from m, where m again is the mod, and we are dividing by m and writing the remainder. Dividing by n and writing the remainder at that point. Now, let us, we can increase the size of this, the size of the group and see what happens, but not so much because it might take long to run. Just increase a bit so that we don't give it, don't wait for it for a long time. This can, I will not, okay. So it generates all the elements of that group. Those are the elements of the group. Now, this summing, you can make it manual. You can make it manual so that you sum the elements you choose. And make it manual, for instance, if you want to sum 1210 and 1211, you just input them. Just input them 1210 and so that you choose the elements you want to choose to sum. And like making it automatic, like the way I've done it, because the way I've done it, if you want to sum 1210 and 1211, you must first of all manually count for you to know which position that element is. Then you tell it, is that okay? And again, you count the other one manually. Again, tell it what position it is. So that will take a long time. I think you can just make your code such that you can input, instead of what I've done here, instead of AB, you can input 1210. And instead of this one, you can input 1211, then it does the sum for you. It does the sum for you. And of course, the sum, how to sum, you will have told it how to sum. I just want to take you through how the code works. How the code works and how you arrive at that. But before that, I want to show you how, okay, let me show you how it works, and then I'll show you where one group is an additive, the other one is multiplicative. Knowing how it works helps to know how to write it. Now, I began with the first part. This part is just to give you the elements of Zn. So that means if Zn, if our n is 8, then you are telling the code, first of all, to generate the elements of Z8, which are 0, 1, 2, 3, all the way up to 7. And that's what it's doing. You see, it's Z8, so it's going through elements from 0 to 8 minus 1. When Rust talks of 0 dot n, it means from 0 to n minus 1. That's what it's doing. So it's running through. You see, you input 8. You input 8, and then it will give you the elements from 0 to 7. That's what it's giving. So that's what this part is doing. So that means if you give it Z8 and give it Z10, you should be able to come up with these elements and also come up with these elements before proceeding this other step, where it's now computing the direct product. So it must first of all know what elements are in Z7 and what elements are in Z10 when it comes to get their products. Now, so it will just be getting the product the same way we've been doing. The same way we've been doing, for instance, if you have elements of Z3, supposing Z3, these are the elements 0, 1, 2. And let me talk of Z4. These are the elements 0, 1, 2, 3, 4. So it's just combining 0 and each of these elements and then pushing into this vector here, pushing into that vector. That's why I've said for A in Zn, for A in Zn elements, for every A in Zn, and then B in Zm, B is in Zm, it pushes that combination of those two elements. It pushes the combination of those two elements to be an element of this direct product. So for what that means for A in Z, that means for every element here, for every element in Z3, and for every element in this, so it begins with this 0. Begins with this 0, combines with the 0, 0 combines with 1, 0 combines with 2, 0 combines with 3. That is what this part means. So after combining 0 and 0, it pushes into that vector. So that means it becomes an element of that direct product. Then 0 with 1 again pushes that. Then 0 with the 2 pushes that, and so on. So that's what this part means. So it becomes a product. Every element in Zn combines with every element in Zm to become a product. Then when you tell it to add, for instance, you tell it to add AB plus AF, it will notice that A is from the first group, E is from the first group, so those two are combined together. After being combined together, divides with the mode of that group. So this is from the group Zn. So adds A and E, and then divides with the N. Then writes the remainder. That's what it does. This is what this part means. This part means A plus E divided by N, the remainder of that. The remainder of that is what is written here. Then there's a comma, because this is the first element. And the second element, you take the elements from the other group, B and F. They're coming from ZM. So add those two, divide by M, and write the remainder. That's what it means. So that's what is happening at that point. That's what it's doing at that point. So you're just doing what we've been doing. Now, when it comes to the inverse, you wanted to get the inverse of TS. You'd have to realize that T is coming from Zn, which is an additive group. To get the inverse of T from Zn, you subtract T from N. Subtract T from N. Now, this part is just to ensure that the answer you're getting is positive. So it's dividing the answer that we get by N, then writing the remainder, just to ensure that your answer is positive. And again, to get the inverse of S, it notes that S is coming from Zm, which is an additive group. So subtracts S from M. And again, to note that to have the answer being positive, divides by M and writes the remainder. So that is just to ensure that your answer is positive. That is what is happening at that point. So it's very easy to design it to get inverse in this. To get inverse when groups are both additive. But when one group is multiplicative or both are multiplicative, then the inverse would be found by the extended Euclidean algorithm which we learned. That is how then it will get the inverse. I just want to show you the code where one group is multiplicative. You see how to get the inverse. Okay, this is the code. Now, so in this code, my second group is multiplicative. This is why I've said Zn cross Zm star. So Zm star that is multiplicative. Is that okay? That is multiplicative. So where are we getting the inverse? This is where we're getting the inverse. Now, the inverse of the first element is very easy. The element coming from the additive group, that one is very easy. But the element coming from the multiplicative group, we are using the extended Euclidean algorithm. The extended Euclidean algorithm to get the inverse. But the one from the additive group, just subtracting the element from the mod, you get the inverse. So that becomes very easy. Again, just like in the previous one, I told it to be counting, but I didn't verify whether it's counting properly. But it generates the elements. Then the product of these two elements, it has to note that the first element is 0 and this 0 are coming from an additive group, and so you add them to get 0. And these other elements, 1 and 2, are coming from the second group, mod 7. So you multiply them because they're coming from a multiplicative group, you get 2. Then the inverse of 0 will be 0. The inverse of 2 mod 7 will be 4. So that 2 times 4 mod 7 gives you 1. So 4 becomes the inverse of that. You can change your AB. AB, I can let me talk of 4 element, the 4th element and the 6th element. The 6th element for, I don't know whether the 6th element is there. I've not counted, but let's try and see. Now, if that element is not there, it will tell us that the element is not, the 6th element is not there. For this case, it's there. In this case, the 4th element is this, and the 6th element is this. So when you do the multiplication, 0 and 1 are coming from the additive group. So you add them and you get 1. But 5 and 1 are coming from a multiplicative group, so multiply them. Let me again change. This one will be 8. And this one will be 9. And I also want to change the inverse. I want the inverse for the 8th element. Now, so the eighth element is this. The 9th element is this. 1 and 1 are from additive group, so that gives us 2. 3 and 4 are from multiplicative group, that is 12. Mod 7, that gives us 5. Mod 7, that gives us 5. Is that okay? And then the inverse, 1 is from the additive group, mod 5. That means subtract 1 from 5, that gives us 4. So the inverse of 1 is 4. But 3 is coming from a multiplicative group, mod 7. So the inverse will be 5, because 3 times 5 is 15. 15 divided by 7, that gives you 1. So that is correct. So the arithmetic there is correct. What I don't know whether it's correct is the counting. I've not counted, but the multiplication there is correct. Now, how my codes work is explained here. The first code, which involved only additive groups, we have that part, and that part we said was to generate the elements of a group. So it generates all the elements of Zn, and it notes when it talks of from 0 to n, I've already explained that. It means it's going to generate elements of 0, 1, 2, 3, up to n minus 1. That's what it's going to do. Then this other part is to compute the direct product. And I've already explained that. And then addition, I've already explained that. It checks the first element A is from which group and E is from which group, then combines those two. Then B is from the second group, F is also from the second group, combines those two. That I had explained. Then the inverse, I had also explained how it does for an additive group. Now, what about multiplicative group? The code for the multiplicative group that I've just shown is also here included. And then you can go through how it works. Oh, I had included the library. I didn't talk about the library. I'm using the num, which imports the integer trait for numcrate that allows us to perform operations like the greatest common divisor and so on, and even modular arithmetic. So if you want to do greatest common divisor and modular arithmetic, as we've always been doing, we've always been importing this library to assist us do that. Now the main function, we know what it does, and then we have this part for generating the elements of this group. Generates the elements of the multiplicative group before it goes to getting the direct product. So after generating those elements, it then comes here and does the direct product. And then it prints the elements. Then when it comes to adding, it has to note that A and E are coming from the same group. The group is an additive group. And then B and F are coming from the same group, which is multiplicative. So it multiplies. This is multiplication. So it must note that these two, the first two are coming from an additive group, and the second two are coming from multiplicative group. So it multiplies them, divides by 11, m, and then writes the remainder. That's what it does. Then for the inverse, for the first element, which is from the additive group, is just subtracting. But for the second element, it's using the Euclidean algorithm to do that. Any question or addition? Can I have some break?